Okay, so lesson 1, we're going to be talking about domain and range. So you should have heard those two terms before in Algebra 1. So notice this first part is just some definitions here. So it says the blank is the set of all input values, which are your independent and your x values of the relation or function. So that is your domain. And then it says the blank is the set of all output values, which is your dependent variable, and your y values of a relation or function, which is called your range. So domain is x, range is y. Independent is your x, dependent is your y. So it says a function or relation has blank, domain, and range if its values are unbroken over a part of a graph. So that is called continuous. So it's considered a continuous domain and range if there's not any broken parts. So a function or relation has blank, domain, and range if its values are not connected. That is called a discrete. And then it says write domain and range. You're always wanting it to write it from least to greatest. Okay, so that's just a little bit of definitions before we get started actually looking at a graph. So now let's look at those graphs. So example 1 wants us to classify it as discrete or continuous. If you notice, we do have a V here. And notice that it's unbroken, so this would be continuous. We're going to write a verbal description of the domain and range. So remember, domain is x, and then your range is your y. So if we look at the x-axis here, notice it's continuous to the left and to the right. So your domain, I'll just write a D here. In verbal description, I would just put all real numbers because it's continuous. And then if you look at the range, which is your y, notice the y-axis here, it's at, that V ends at -1, and it's everything above it on the y-axis, which would be everything greater than that -1. So notice also it does include it on that point on the V. So we would write it as all real numbers greater than or equal to -1. So that's our verbal description. So there's going to be different ways of writing our domain and range. So that's what we're going over now. So we did the verbal description. Now we're going to use inequality notation, which just means a less than or greater than, things like that. So I'm going to go ahead and label domain. And remember, our domain is all real numbers, so there's a symbol for that. It's 2 vertical lines and then connect the R. So that's all real number symbol. And then your range, we wrote it as a verbal description of all real numbers greater than or equal to -1. So we would have y is greater than or equal to -1. So that's inequality notation using your inequality sign. We didn't have to use that on domain because it was all real numbers. Okay, so the next notation that we're going to be going over, so you've probably looked at inequality notation before. You've probably seen that. Set notation is probably something you have not seen. So it's going to look weird, but it's just a different type of notation. So it's really not difficult. You just have to know how to write it. So our domain, on set notation, you have to use curly brackets. Do the best that you can. And then you'll have domain is x. I'm going to put an x and then just put a straight vertical line, and then you'll put another x, and then you'll have a little e that's a curve. and we're talking about all real numbers. So I'm going to put that symbol, all real numbers, and I'll close my bracket. So now let's go over what that means. So this means the set of all numbers x, and x is an element. That's what that little e is, of the set of all real numbers. So again, it looks weird, but it's really not difficult. You just have to know your notation. So now I'm going to go to range. I'm going to use my curly bracket. I'm now using a y because we're talking about the y. I'm going to still do, every time you do set, you have to use the y and that straight vertical line. Another y, we'll do element of, and then it's all real numbers that are greater than or equal to -1. So again, notice it's very similar to that, except we're having to use all that other notation. So what that means is the set of all y values is an element of all real numbers that are greater than or equal to -1. So again, it looks kind of confusing, but it's really not difficult, just needing to know that that's how the form is with set notation. Interval notation probably is something else that you have not seen. So we're still going to be looking for domain and range. On interval notation, I think it's pretty easy. You're always just starting with your smallest x or y value, and then you're going to your largest x or y value. So on domain, it was all real numbers. So if you look, the smallest x value that would be used is -infinity, and it goes all the way to +infinity because we're using all real numbers. Now, next to the infinity sign, you'll put a parenthesis because it's never ending, it never stops. So it's not going to include any, it's just going to keep going and going and going and going. The range, if you look at your y-axis, the smallest, if you look at the graph, so the smallest y value would be -1, and it keeps going up, so it would be +infinity. So parentheses goes around things that is not included, and then a bracket goes around things that are included. So it does include -1, so we're going to put a bracket, and then around or next to the infinity, we're always using a parenthesis because it's not stopping. It just keeps going. Okay, so those are the different notations that we're going to be looking at for domain and range. They all mean the same exact thing. So you just need to practice them, and then it should be better. So, okay, so let's look at example 2. So notice here that we have points and we don't have lines in between. It's not connected, which means there is a space between them. That means that this is a discrete graph. So we need a verbal description of our domain and range. So if we look at the x, that's our domain. Notice, what is that, -6, and then it jumps to -4, jumps to -2, 0, 2, 4, and 6 there. So those are our x values that we're using on these points. So notice that it is all even numbers between -6 and +6, but also notice that it's not including those decimals or fractions in between each whole number. Okay, so what we're going to write for the verbal description for this domain is all even integers, which means whole numbers, between -6 and +6. Okay, so now let's look at the range, which is the y. So notice at the bottom here, that is -6. And then that would be that would be 5, -4, -3, -2, -1, and 0. If you're looking at the y-axis. So the range would be all integers, because it's not any decimals or fractions, between -6 and 0. So basically you're just having to look at your graph, looking at the x-axis for domain, looking at the y-axis for range. The interval notation, which means inequalities, which would be a greater than or a less than, we're not including all of these values in here. So this is not applicable. So just write NA there, because it's only these set numbers. It stops, nothing in between. Okay, so the set notation, so domain, we're going to use a curly bracket. And then on this one, it's much easier than the last one. You don't have to worry about all that notation stuff. We're just listing out those numbers. So our x values are -6, -4, -2, 0, 2, 4, and 6. Remember, we do least to greatest on listing out our domain and range. Our range values are between -6 and 0, so all integers. So -6, -5, -4, -3, -2, -1, and 0. Close your bracket. So when it's discrete here, you're just listing out those values that you have on your graph, because it's not continuous. It's not in between each little whole number integer there. Interval notation, same thing as the inequality notation. We're not able to have an interval notation because it is just those integers, those numbers. So that one was pretty easy. All right, so let's look at example 3. So notice it does stop, but do notice that it includes all of the fractions, decimals in between each whole number as well. So this is still continuous. Okay, so the verbal description, look at your x-axis for domain. This value here is -8. And then it goes to this value here, which is +8. And notice it's including every single decimal fraction in between each whole number, which is called an integer. So it does include it. So we are going to do our verbal description for the domain. It's all real numbers between, and it also includes, so put and including, -8 and +8. Okay, so then looking at the range, so looking at the y-axis, so go down, that's going to be right here, so that's a 3, and it goes all the way up to this mark, which is a 7. So this is also including, so all real numbers between and including 3 and 7. So the inequality notation for the domain, it's in between on the x, in between -8 and 8, and it includes all the numbers in between. So we're just going to have an and statement. So in between -8 and 8, and -8 is less than, so we'll use less than symbols. And then it includes both of them, so make sure you put the equals too. Okay, so then the range Looking at the y-axis, that's between 3 and 7, so make sure you include a y on this. So 3 is less than 7, so use your less than symbols, and then it also includes those two values. So there's your inequality notation there. Again, that's probably something you're used to from Algebra 1. Set notation. So we're going to use a curly bracket. We will have an inequality in there, so make sure you're doing the X and then that vertical bar, which means the set of all X's. And then we'll have that X and then the E, which is the element of all real numbers. Put a comma and then X. Go back. Your inequality, -8 between -8 and +8, and it includes it. So all real numbers between -8 and 8 is what that means. Looking at the range, so we're going to have our curly bracket, the y, the set of all y's is, and then y is the element of all real numbers. And then our y values are between 3 and 7. So notice that these two are very similar. The only difference is this notation here. So don't let that confuse you. You just need to know how to write it for set notation. Interval notation, remember that one's pretty easy. You always start with your smallest. So our smallest x value is -8, and it goes to +8, so put a comma in between. It does include -8, so put a bracket, and it does include 8, so put a bracket there as well. Your range, the smallest number is 3, and it's everything in between 3 and 7. It includes both, so remember brackets when it's included. Okay, so there's a couple of graph examples and then figuring out our different notations. So let's look at the back. So we can easily switch between each forms, the different notations. So we just went over parentheses for a less than or a greater than, square brackets for an equal to. So exclusive and inclusive. So example 4, it says rewrite the domain and the range in set notation and interval notation. So I'm going to do set and then interval notation. So I'm given the domain as x is greater than 0. So I'll start with set notation. So remember that's the weird one. So curly bracket, we'll have x, vertical bar, x is an element of all real numbers, comma, that are greater than 0. So there's our set notation for that one. Now our interval notation. Remember that's the easy one, so start with the smallest x value, which would be 0, because it's greater than 0, and it goes all the way to positive infinity. It does not include 0. Notice there's not an equal to there, so it will be a parenthesis next to that. And remember, it's always parentheses next to the infinity because it just keeps going. All right, now let's look at the range. The range is all real numbers. So for our set, curly bracket, our y is the set, and then y is an element of all real numbers. And since we don't have anything else, that is it on that one. So for our interval one, remember all real numbers is negative infinity to positive infinity. Okay, so why don't you go ahead and pause and try and figure out this next one on your own, and then I'll go ahead and put the answers, so once you're done, then you can replay. So the domain, this one we're doing inequality and set. So the inequality is all real numbers. The set is curly bracket, X is a set and an element of all real numbers. And then the range here, the inequality. It goes from 0 to infinity, so y would have to be greater than or equal to 0. Notice it's equal because of that bracket. And then the set for that, y is an element of all real numbers, comma, y is greater than or equal to 0. So there's the different forms. So we're just going to be practicing writing all the different forms. This next part, it says graphs of different functions can share the same domain but look different. So notice here, first off, this is an absolute value graph because it's a V. And notice that the parent function is y equals absolute value of x. The domain is all real numbers. The range is y is greater than 0. Notice this one here is a quadratic because it's a parabola. It also has the same exact domain and range as the absolute value. So just because it's a different graph doesn't mean it's necessarily going to be a different domain and range. So it can look different but still have that same domain and range. So this next part, we're going to be creating graphs that satisfy the domain and range given below. So you might have to put a little bit of thought into it. So notice on this first one, the domain and range is both negative infinity to infinity, which means all real numbers. What that tells me is it's never going to stop. It's going continuously in all directions. So a good example would just be a linear equation. So arrows at both ends, it goes continuously to the left, right, up, and down. Now there's several different ways of putting a graph that's all real numbers for domain and range. So that's just one example. Okay, so then the next one, it says the domain is x is greater than or equal to 0, which means all positive values. And then the range is y is also greater than or equal to 0. So that means that this is going to stop because we're only using positive x's and positive y's. So, and it does include 0. So I'm just going to go ahead and put a point there, and it's going to be in that first quadrant because we're only using positive x's and y's. So that's an example of that one. Okay, so this next one, the domain is between -4 and 5. So it is including all those decimals and fractions in between -4 on the x, which is there, and +5 on the x as well. 1, 2, 3, 4, 5. And then the range is in between -5 and +2. So I'm going to go ahead and plot my points. And then I'm going to connect it. So that's one way of doing it. You could draw a straight line, you could zigzag as long as it's in between those 2 points. That should have been a Y there. Okay, there's your domain and range. If you have any questions, make sure that you come and see me.